Hello students, in this video I am going to demonstrate the experiment number 4, how to simulate it in using auto simulated using simulation software called FluidSIM demo version. The experiment number 4 title is like signal storage by means of electrical self-locking and reset by means of proximity switch. That means there is a hydraulic circuit and there is a hydraulic cylinder. Sometimes in applications, hydraulic cylinder complete stroke movement is not required. That means, say for example, cylinder stroke in the laboratory we are using is 20 centimeter or 200 mm stroke. Sometimes it is required to extend of the cylinder only half of the stroke or any stroke length less than 20 centimeter or 200 mm. So how can we limit the stroke of the cylinder, even though it can go up to 200 mm, but how can we limit before 200 mm? So by using proximity sensor, which can be contact type or contactless type, we can control the stroke of the cylinder. Displacement of the cylinder can be controlled. So in the laboratory, as you conducted the experiment, we are using contactless inductive sensor. Inductive proximity sensor is used in the laboratory, right? So that is what here B1 is a sensor, and there is a hydraulic cylinder. DW9 is hydraulic cylinder. So cylinder stroke can be controlled, can be monitored using with the help of proximity sensor. So I'll show you how to how to make the hydraulic circuit and electrical relay circuit in the simulation software. Let us open the software. That is yeah, it is here, FluidSIM. Double click on this. Now software is open. Go to the new file. Here the area, the drawing area is less, right? That you can change it actually. Go to the file or in the edit option. Just looking for that. Yeah, page setup. In the page setup, we can go for A0. A0 is the largest, we can say, sheet size. Okay, I think it is not in the demo version. The drawing area we have to be, we have to increase. It's okay. This is a small experiment. So go to the hydraulic library. In the actuator, take the cylinder. This is a cylinder. And as per the hydraulic circuit, what is the requirement? There is a double acting cylinder is there. One throttle check valve is required. One 4x2 direction control is required, solenoid operated, and one pressure relief valve is required. One pressure gauge is required, and one proximity sensor is required. That is B1 sensor, right? So here cylinder is placed vertically. So if you want to have a same moment, that is also possible. So I'll just rotate this by 90 degree, and okay, that is, we want it mirror it in vertical. Yeah, this is what required. And we have to take one 4x2 direction control valve that is available in direction control valve, solenoid operated, the first valve, and then go to the flow control valve. There is a throttle check valve is there. Let me see the direction here. Yeah, it's perfect. A is connected to rod chamber. A is connected to rod chamber, and B is connected to the throttle check valve. And in the supply elements, there is a pump and it's a tank. So since it's a fixed displacement pump, protection is required. Again, is the overpressure. Go to the pressure control valve. So pressure control valve. And here one more tank is required. And obviously there is a pressure gauge is required to monitor the pressure or display the pressure. So pressure gauge. And the solenoid name is Y1. And there is a sensor. Now many of the students they are asking like how to add sensor to the cylinder, right? So double click on the cylinder, go to the property, component property. Here the stroke, cylinder stroke, it is in inch, so but we want it in mm. Almost 200 mm is there. 199.99 means 200 mm. So go to the actuating labels. So you know the cylinder stroke, right? 200 mm. So now go to the actuating labels. Here you can add sensors. So name of the sensor, I'll give it as B1. Sensor name is B1. So now where you want to place the B1 sensor? What is the range? You can place the sensor between 0 to 200 mm. So I want it in mm. So 0 to 200 mm. For example, I want the cylinder to be extended only half of the stroke. That means 100 mm. And after completing 100 mm of stroke, it should return back. So how can I do that? So I can place sensor at 100 mm. Start and end point is same. Only one sensor is there, or you can add some more sensor in the next upcoming circuits. So click on OK. Now sensor is added. What is the sensor position? 100 mm. So you can see here 100 mm. Okay. So this is the hydraulic circuit part. Now hydraulic circuit is over. Now electrical circuit is there. In the electrical circuit, there is one single switch is there. That is SY. And K1 relay and K2 relay is there. There is one sensor is there, and one solenoid is there. Okay, so let me draw this. Go to the IEC standard. IEC standard. Their power supply operating voltage of solenoid is 24 volt DC. So sheet size to be increased. Let us see. Otherwise, I will push this here because I need more space for the electrical diagram. Now, switches in the manual operated switches, there is a normally open switch. So that is named as, double click on the switch, and in the identification you have to type S5, and it is connected to 24 volts. And there is a relay. We'll take one relay. So that is sorry, this is a relay, and here double click on it, and you have to type it as K1. K1 is a first relay. Okay. See, this SY is a push button, right? I don't want to hold the switch continuously, so I want to have a latching function. So what I'll do, signal storage function. I'll take one normally open contact and keep parallel to this switch, and double click on it and link it to K1. Okay. So by operating S5, our requirement is cylinder should be moving upward, right? Continuously it should move upward. So whenever K1 is on, solenoid Y1 should be on. So what I'll do, I'll take first solenoid and then I'll take one more contact. This is Y1. Okay, this is K1. So what I'll do is I'll just simulate this part. Let us see what is the significance of proximity sensor. Go to simulation. If you press switch S5 once, that is enough. Cylinder is continuously moving upward and completing the full stroke. But our requirement is not the full stroke, only half of the stroke. So we have placed exactly B1 sensor at 100 mm displacement, right? So now in order to use the proximity sensor in the circuit, what I can do is, see what you observed is here. What observation you have to make it here. If relay K1 is on, then solenoid will be on. If solenoid is on, cylinder is moving upward. If solenoid is off, cylinder will move downward. So here the requirement is whenever sensor is on, we should switch off the relay K1 so that solenoid Y1 is off, so that cylinder will move downward. So what I'll do is I'll take one normal inductive sensor. Let me see that where it is there. Yeah, it is there. It is an inductive sensor is here in the measuring instruments and sensors. So one is it is having positive and negative, that is a power supply, and output I will take it to the second relay called K2. So this is K2. Meaning is when sensor, this is a sensor B1, right? I have to link it. So double click on the sensor and link in the identification type B1. So that software understand that this B1 and this B1 is linked. So this B1 is nothing but sensor. So if sensor is on, K2 is on. So you know that when K2 relay is on, so you want to switch off K1. So what I should use normally close contact of K2 in the line of K1. Normally close contact, and we have to link it to K2. So if sensor B1 is on, K2 is on. When K2 is on, since K2 is normally close contact is used, that will become open. When this becomes open, it is going to break the circuit of K1. So K1 is off, Y1 is off, and cylinder will not continue in forward direction. Instead, it will retract back to the home position. Let's go to the simulation. If you press S5 once, S5 button once, and you can also, that the speed is high, I'll show it in a slow motion. Okay, if you press S5, cylinder is moving. Whenever it reaches B1 sensor, it is returning. Since we are using throttle check valve, it is controlling the velocity only in forward direction. In return direction, there is no control. Show one more time when you operate S5. And in the previous video already mentioned how to make a report and submit as assignment, right, in the Word file. Please refer the earlier videos and submit the assignment. So since it's a demo version, I cannot save this. You have to save it in the Word file. Thank you everyone. If you like this video, please subscribe to my YouTube channel. Thank you.